In no way whatsoever do we accept responsibility for the quality of construction, safety of this project, or anything that might result from the use of this product. The complete responsibility depends on you, the person building it. It is your decision on how to build it. The video is only a guide.
The metal around the axle, just simply pushing on it and bending it is light enough that you can just bend the metal right around on the axle. The seam will end up in the middle on the back side. Turn it around and bend the metal up on this side. Then you take your two C-clamps and clamp it together. You want to check to make it sure that it's still flat on the bottom, still square on the bottom. And it is. So you check that. Now you re-tack weld it on all the four corners, and then just finish bending it around, and then finish welding it. Simple procedure, very strong, solid axle. Okay, we've tacked it on both sides. Now we're just going to roll the metal around, reclamp it, and then finish weld it. It's simple. You just put some pressure on it and push it down, and it will roll right around. Just like that. Very simple. Goes right around, comes up in the right spot, and then all you have to do is reclamp it again. And finish welding it, and it's completed. As you can see, we have finished welding it. We welded it, seam welded the whole distance around. It's a very strong unit. You can take and finish, grind it off so that it's nice and smooth, and fill any dents you have with body filler if necessary after you weld it on to the front end. So this is your completed front stretched axle. Okay, now we're going to go over the sectioning of the rear deck lid. Okay, what we had to do was we had to widen the deck lid 9 inches. So what we do is we lay it out 7 inches from the center. We tape it and mark it and cut it, radius it all the way around, cut 7 inches out of the center section, and then we split it down the middle. Simple procedure. We cut that piece out so that the deck will be wider for our wider Pro Street stance. Then we make the countersunk parts for the seat. Next, this piece, which is 46 inches by 6 inches, this is the seat back for the deck lid. And this you just bend right around and fit right in here and tack weld it as you go around. Then you fit in your next piece, which is the bottom of the seat. That's also 16 gauge. It's 16-inch square piece of metal that's rounded on each corner, 2 back corners, that fits in the bottom. This is a 9 by 7.5 inch splice that goes in the rear deck lid and is bent around to match. And this is the front deck lid. It's 16 by 7 inches, and that's the piece that goes in the front just like this. And then these dimensions are 3 by 12, where it's tapered on the bottom. The shifter comes through here you'll lay that out at a later time. Cut. Section out 7 inches out of the rear deck lid. You can do it with a Sawzall, you can do it with a jigsaw, you can do it with a plasma cutter or a torch. We're going to use this Sawzall on this application here. All you do is you hold down the rear deck lid, turn the saw upside down, simply turn it on. This is the shears. As you can see, we laid this out with tape so you could plainly see where you're supposed to cut. As you can see, I didn't bother to cut it where I laid it out. I had a minor distraction that distracted me. You could get mad when you screw up like this, but it isn't going to do you any good, so you might as well just laugh and say to heck with it. So anyhow, this thing is going to be now a ½ inch shorter than it was supposed to be. It's not that critical, really. So now I'm going to finish cutting this out with the shear. But like I say, we're doing this for fun, and if you make a mistake, it's not that big a deal. Now we're going to show you how to form the rear deck lid splice. It's simple and easy to do if you follow the directions. What we did is we measured it, found the center of the radius, and simply formed it over a 3-inch piece of exhaust pipe. Just took and bent it around by hand until it formed the right radius. Then we took and formed the rear lip simply by taking that out. We used the vise as a brake to bend the metal. Put it in. Apply firm pressure on the top and hit the sheet metal right on the brake to bend it down. Move it back and forth a couple times until you get it just right. Measure it a couple times and check it. Make sure it fits properly. Then measure the top bend. Install that. Same thing, apply firm pressure. Tap right next to the bend until that fits perfectly. We made the piece 7.5 inches long, which is a ½ inch too long. In case you were off a little bit, you could trim it to get it just right. We made what's called a butt seam weld. You butt the two pieces together. You could make a lap seam weld. Then you have to have a dimpling tool to make the lap seam for this. We don't have one of those, and most people don't. If you do, you have to make this piece wider to compensate for that. And then you'd have a lap seam, which is better if you have the tool to do it. And now we are going to weld this together and finish doing it. I'm going to go over the splicing of the section on the rear deck lid. We splice in this piece that's supposed to be 9 inches, but since we cut it off a ½ inch too short, it's only 8.5 inches. The main thing is that it's 16 inches in the back and 16 inches in the front so that it's square. Okay, and as you can see, we just tack weld the piece in. Now we're going to tack weld this piece in, and then we'll go to the back of the seat next. Now we're going to show you the bottom and the top view of the rear deck lid. We just finished measuring and fitting for the bend radius for the seat back. It fit perfectly. All you have to do is tack it in with your spot welds and then tap it with a hammer and fit it as you go. Then you weld in the bottom of the seat and weld in the front of the deck lid. There's certain areas, due to the fact that the deck lid is probably old and somewhat bent, you might have to add in a splice here or here. Even though you measured it correctly, it still might need a little bit of an adjustment. But this will show you the bottom and the top of the rear finished deck lid. All you have to do is grind it a little bit to finish it off when you paint it and fill in the holes with body filler.
We're going to go over the engine cross-member motor mounts. They're 12 3/4 inches wide, 1.5 inches deep, and either 1/4 or 3/16 of an inch thick. We use 3/8 inch bolts, and we drill the holes 13/32 of an inch to give you a little room to play with. The holes are drilled 2.5 inches in from the end and 1 1/8 inches down from the top to the center of the bolt hole. The next hole is drilled 7 5/8 of an inch from center to center and 1 1/8 inches up from the bottom. Both motor mount cross members are the same. They're just flipped over upside down, one for the top and one for the bottom. We also took and cut 1 1/4 inches off the end of the crankshaft so it will clear the floor pan. We cut that off with a Sawzall. Now we're going to go over the modifications we've made to the frame. First, we welded the axle on at the same angle that the frame was cut to. This gives you the caster for the front axle. The caster gives your vehicle better handling ability at high speeds and at low speeds. When we welded it on, we also welded the axle back to the axle to give it a little extra strength here at this seam point. Then we welded it in the center and also on the opposite side. Then we cut the pitman arm down on the steering so that it would clear the hood when you turn. Next, we made the hood mounts out of 7/16 inch threaded rod. They're mounted 3 inches from the edge of the frame to the outside and welded to the frame rail. You can adjust them with the nuts and cut off any excess if you need to. You set the motor mounts for the engine. The first one is set back 12 inches from the front axle, and they're set on pieces of plywood that are 2.5 inches wide. You just set these in there, and then you can set the engine mounts right on top of that, and then clamp the frame rails together and weld them. We're going to go over the modifications we've made to the steering and the firewall. First, we mount the steering cross member 23 inches back from the front axle. You also have to make sure when you're installing the engine that it clears when it's turned all the way to the left, because the rack comes out towards the front. We also did some modifications to the firewall. We put a block of 2x4 where the steering column goes through the firewall and screwed it onto the steering column, screwed it onto the firewall. Then we drilled a pilot hole that is perpendicular to the floor pan through the 2x4. Then we drilled a finished hole that is 7/8 of an inch in diameter, which is the outside diameter of our pipe, and fit it through there. The floor pan dimensions are 13 inches wide by 8.5 inches long, and that is welded directly to the firewall at the proper angle, which is approximately 68 degrees, the same angle as in the Murray lawnmower. We also mounted a bolt hole through here. The nut is welded on the inside of the frame, so it's easy to remove and install. And that is 26 7/8 of an inch back from the front axle is where this hole is located, and it will be approximately an inch down from the frame. The total height of the firewall should be 11 3/4 inches. As you can see, we made another mistake and cut it off too short. So we just kind of added these pieces of plywood in on the top to compensate for the mistake we made. And it's okay to make mistakes. We make them all the time. Anyhow, that's the end of the steering section. Install the engine in the proper location, which we already have our blocks set in here in place, 12 inches from the front of the axle. You simply turn this back all the way, make it easier. Pick the engine up and just set it in on top of the blocks and wiggle it around till you get it in exactly the right location. You also have to have the gas tank mounted and make sure that it clears the hood. One of the first things you want to do is remove the gas tank, drain it, wash it out, and then you can use it when necessary to make your fittings and alignments. But you want to make sure that you wash it out with hot water and that there's less chance of a fire or an explosion because you don't have any gas in it, because that can happen and it can be dangerous. So make sure you do this as one of the first things that you do. You're also going to have to modify the air cleaner somewhat so that it will clear the hood line. And we'll go over that at a later time. Now, you take some clamps and you clamp the frame together and then weld the mounts in place after you have sure that you got the engine lined up in the proper location. Clamp and weld the motor mount brackets in place. You take a long clamp and you clamp the frame rails together until they touch the motor mounts and are tight. Then you tack weld the motor mount brackets in place on all four corners and clamp it on the back also. Then you simply undo the bolts that hold the motor in place, remove the engine, then you can finish weld the joint after you have tack welded it. Then you take a 3/8 inch drill and drill through your motor mount bolt holes down through the floor pan. Then you drill up from the bottom with another drill bit that's just slightly bigger than the diameter of your socket so that you can easily remove the engine the next time with your socket and ratchet from the bottom instead of trying to get your hand up through the engine hole like you had to do to remove it just now. And that will simplify the operation the next time you remove the engine. A few of the things we did to the front end. What we did is we installed the kingpin bushings. If they're loose in the axle housing, you can take a hammer and beat on this part here until it's a tight fit. You might have to even beat on it from the side, but with the little hammering you can get this to fit tight if they're loose. Also, you have a cotter pin that used to be on the top is now on the bottom. It also holds all the weight of the front end. So you want to check these periodically and make sure they're not wore out. Or you could also weld a piece on there permanently so that you know it's not going to fall off, but then it's kind of hard to take it apart. Also, now that the axle is turned upside down, the wear point that used to be on the bottom is now on the top, so it's just about like a new axle. And also, you'll most likely want to put new bushings in the wheels and grease them. Also, we welded stops in for the turning of the front axle. All they are 5/16 nuts that hit the axle parallel, and there's one on each end.
They work very well for that. The next thing we did is we made a filler plate between the hood and the frame so it looks better, and it also strengthens the frame. This piece is 26 inches long. It's 3.5 inches high on one end and 2 inches high on the other end, with a 1/4 inch lip bent on the top edge to give it some strength. And also it's tipped out 1/4 inch so that it will clear the starter when the engine is in here, and plus it looks neater. We just tack welded it in now. We'll finish weld it after we sandblast the frame and we weld in all the rest of our other holes. Then we'll go back to the rear axle where we had to do a little work. On almost all the used mowers that you get, one of the axles will probably be bad. You can use this as a point to Jew the man down when you're trying to buy the thing from them, because it costs a lot of money to fix these under normal conditions. If you went to buy a new axle, each axle will cost you about $25, and a bushing, a bearing, and seal kit will cost you about $10. So that can add up to about $70 just for the rear axles if they're bad. And at least one of them will be bad. I can almost guarantee that. But we know how to fix them for a lot less because we're smart. All you have to do is go to an industrial bearing place and get a bronze or brass bushing that is 1.5 inches long, 1 inch outside diameter, and 3/4 inch inside diameter, which is the diameter of the axle. Then when you put it on, when it fits on, it will go over the bad spot, and grease will fill in where the bad spot is, and this bushing will last longer than the bearings that you could buy. Plus, you don't have to buy a new axle, and you also don't need a seal. And you can just hammer it right into where the old bearing was. So it's a really good, cheap way of fixing a bad axle. Okay. As you can see, that's the way we fix this axle here. We have a new bushing in where the bearing used to be, and we don't even use a seal. There might be a little bit of oil that comes out, but I don't think that'd be a problem. We also had to weld a nut onto the end of the axle so that we could space the wheel out just a little bit farther. Okay, it's very important when you do that to do it correctly. You have to have a good ground when you weld to anything. So you want to have a spot where there's no paint on it, like this. You want to have a good clean spot like this where all the paint has been removed and you can get a good ground. When you're grounding something and you're welding it, sometimes your weld won't be as good as you want it to be. That could be because you have a poor ground. So feel the clamp. If it's hot up by the top piece, that means you have a bad connection here. If it's hot in the handle, that means the handle connection is bad, and that can be giving you a bad weld. So it's very important to know what you're doing when you're welding. Okay, now what we're going to do is we're going to make believe we're going to weld this nut onto this axle. And we would go about it by welding, holding the nut, and then welding this nut onto the axle. Right? Wrong. Actually, I'm just doing this to kind of make some of you guys who know what's going on upset. In reality, this is not the way you want to do it. I'm just doing it to prove a point. Whenever you're welding to something, you want to have the ground hooked as close to it as possible. So for instance, if we were actually going to weld this piece right now, the juice, the electricity, would have to go from the ground clamp through here into the frame through this joint, which would probably cause a spark and also make the weld pour, come through the frame into the axle housing,
through the bearings in the axle housing, which would actually weld little spots onto the bearings and make them go bad at some point in time, before it gets through the axle and comes out to where you're welding. So that is one thing you never want to do. So whenever you're welding something, especially a moving part where there's any bearings, you want to clamp as close to that piece as possible and weld it on like this. The other thing you can do to save some money, depending on how fast you want it to go, is you can take the pulleys that were on the engine and cut them up and weld it onto the pulley that's on the transaxle. You just cut it off, center it, and weld it right onto here, and that gives you a good pulley diameter for this. And it also makes this the brake. We use this as a belt brake pulley. I'll show you that later, and it's a good braking system now that you're going to be going a little bit faster. Go over the braking system. We added a 4-inch extension to the brake lever after we angled it back using the original holes that were drilled into the frame. We enlarged the bottom one, and we used the original bracket for the brake rod and ground off the top until it fit underneath the motor mount, which gave us the right dimension for it to line up perfectly from the bottom. Then we took the original lever that was on the brake rod and cut it down so it just misses the motor mount and welded it on to the brake rod. We also used the original brake rod to go to the back and hooked it on to the disc brake like it normally was, but we also added a belt brake. It's a belt friction brake. The end of this belt is tied onto the frame so the belt does not move. When you step on the brake, this rubs against this big diameter pulley and stops the wheels from turning through the differential. You can adjust these proportionally so they're both applying brakes at the same time. Now, due to the fact that this low mower, Pro Street mower, will go a lot faster than the lawnmower used to go, you have to have a lot better braking system for it. And that's why we designed this system. And it works very well. It's a 2-system braking so that if one fails, the other one should also stop you. Okay, we also, on the rear end, is you want to make sure that you drain all the old oil out and put 1 quart of new oil in it. You also want to put in some super duper oil additive so that it can take the high speed that it's going to be going at. Another thing that you should do is fix this nose cone. What happens is the oil can run out through this due to the fact that this seal is probably bad over the years. You can take this piece apart and polish it up so it works better, this ball that's in here, and fits better, and put a new seal in the end of this to keep it from leaking, because now it's upside down and it will have a tendency to leak. We had to cut a notch out that is 3/4 of an inch deep and 1 foot long so that it'll clear the drag length when you turn. As you can see, it just barely clears. It could be a little bit closer here. Another thing you want to make note of is the steering column. We finished that. You want to mark which way this goes in so that it's easier to install, because it'll probably only fit one way unless you drill that hole perfectly, which I doubt, because I didn't. Then we also polished it where it goes through the steering column so it turns smoother. Then we took and welded a 3/4 inch nut, not a 3/4 inch, a 3/8 inch nut on the inside of the pipe and a 1-inch flat washer on the top of it, and then that's how we bolt the steering wheel on with just friction. That way you can take this in and out when you want to work on it. In this application, we used the foot clutch for the throttle linkage. We made it very similar to the brake lever, so it's symmetrical, by adding 4 inches to the foot lever. And we drilled the hole through the frame rail at 3/4 of an inch and put it into the original bracket, lined it up just like we did with the brake lever. Then we added a 5/16 inch piece of threaded rod so that you can adjust the leverage. By moving the lock nuts up and down, you change the amount of leverage you have. And that goes through the throttle cable, which we extended up